This is the Week 10 intervention, Concept 10.1. Remember, you're only watching this if you have already completed the problems. If you haven't completed them yet, shut the video down, do the problems first, then watch it to correct. So these are problems with ratios, whole numbers and ratios. You're going to first figure out how much stew is there altogether. So it says Mark is making his famous stew in a slow cooker. We're talking about one serving. So here's what we know. In one serving of stew, there are 5 carrots and 3 turnips. So in every one serving, if we were to do carrots to servings, we would know that 5 carrots in one serving. If we were to do turnips to servings, we would know that there are 3, not 31, there are 3 turnips in one serving. Problem A, there are 33 turnips in the slow cooker. 33 turnips. Every 3 turnips is one serving. How many servings? That's the X. Let me get rid of that and underline it with our X color, red. So here's what we know. We know that in a regular serving, in one serving, there are 3 turnips. So again, we have turnips, we have servings. There are 3 turnips in one serving. Our question is, if there are 33 turnips sitting in that slow cooker, how many servings does that represent? So now we have a proportion, and you've seen a lot of proportions. One of the nice things about going back and doing the intervention for this concept now is we've continued to work with proportions. So if you struggled with this a little bit in the beginning, you've seen a lot more proportion work. So 3 in every one, 33 means X. We have 2 ways we can solve this. Let's do the cross multiplication way first. We would do 3 times X equals 1 times 33. That would mean that 3X is equal to 33. We would divide both of these by the coefficient. Remember, 3 is the coefficient. It tells us what 1 is going to be. So 1 times X. 33 divided by 3 is 11. So what if we stick an 11 there? What if we say X equals 11? Does that make sense? Well, here's the other way we could have solved it. We could have said, how many times does 3 go into 33? 11 times. What's 1 times 11? It would be 11. So we know that with 33 turnips in the slow cooker, Mark is making 11 servings. Mark is making 11 servings. Okay, so if Mark's making 11 servings, now we're on to question B, how many carrots in the slow cooker? That's for these 11 servings. For 11 servings, how many carrots? That becomes the X. So here's what we know. We know that in one serving, the number of carrots is 5. We now know that there are 11 servings. How many carrots will there be? So we can do the same cross multiplication. We would multiply 5 times 11 and 1 times X. We would get 55 equals X times 1, which is just X, 1X. And we don't need to do any division. We don't have any coefficient. We know that there will be, Mark will use or Mark will have 55 carrots in the slow cooker. All right. So now you're going to do one of two things. If you had those two answers, if you had 11 servings for A, that was our answer to A, 11 servings, and you had 55 carrots for B, you probably understand what you're doing. You can move on and just watch the video at the end. Just fast forward to the end, check your work for problem 2. If you didn't have those, then it's time to rework the problems, or at least check problems on 2 with whatever you now realize you didn't figure out before. Check that and then watch the video for 2. And you can just fast forward to the end and see if you got it right. If you get it right, you're ready to go on the intervention test. If you didn't, then you can go back and watch whatever you need to watch to figure out what you didn't understand. Okay, we're ready for the second part. Now, you might look at this problem and you might say, well, hang on a minute. That's a lot different than what we saw with Mark on the slow cooker. It's a different type of problem, you bet, but the mathematics that we're using is the same. We're still using the idea of ratios and proportions. On this one, we're given some information. So let's take a look. Jason painted the exterior of his house using a total of 65 gallons of paint. He mixed 25 gallons of red paint with 40 gallons of blue paint to make the purple color that he wanted. Painted his house purple. You'll notice that if you take all the blue paint, the 40, and you add it to all the red paint, the 25, let's get purple here, 25 plus 40 equals the 65. So we know all the paint is either red or blue. So we're going to create a couple of ratios to start with. I'm going to use space down here on my paper. So here's what we know. We know that the red to the total is 25 to 65. And we know that the blue to the total is 40 to 65. And we can check it one more time. We know that that's all the paint that he needed, because if you add those together, if you add 25 to 65 and 40 to 65, you get 65 to 65. You get one whole amount of paint. So now we're ready to move to part A. Jason decided to paint the interior of his house the same color. He's going to have a purple outside, purple inside. He decided he needs 37 gallons. That's the total. So think of this. Think of these 39 gallons as the total paint to cover all the walls. How much red does he need? So here's what I already know. I know that when I'm going to use the power of my tools right here, I know that the red to the total, boom, 25 to 65. Now what we're saying is, okay, that's great, but what if instead of 65, he just needs 39? He doesn't need 65 total now. He needs 39 total. How much red will he need? So that gives me a proportion problem. That gives me some cross multiplication to do. The 25 times the 39, the 65 times the x. And there isn't a lot of room to work right here, so I'm going to bring my problem all the way to the end here. So here's what I know. I know I have 25 times 39 equals 65 times x. Now, I don't expect you to do all this by hand. I'd prefer actually you used a calculator. You got used to using a calculator. Real tools for real work. So 25 times 39 This is like those nice 2-display calculators. I can see I did the right numbers. 25 times 39, 975 equals 65x. 65 becomes my coefficient. 65 is what I need to divide by because I want 1 right there. So I get 1 times x is x. And 975 divided by 65 gives me 15. So I know, and I started to do Mark because he was the guy in the last problem, and I know Jason needs 15 gallons of red paint to do the inside of his house to get that beautiful purple color he wants. He needs 15 gallons of red paint. Let's get our calculator out here for a moment and let's do part B. Now I'm going to do part B 2 ways. So the first way I'm going to do part B is I'm going to do the same thing I just did with part A. I'm going to bring up this ratio I started with, and I'm going to say that's great, but now he doesn't need 65, he needs 39. So how much blue will he need? I'm going to have the same cross multiplication idea. So I've got 40. Let me get that back to my blue. I've got 40 times 39. And I've got 65 times x. So 65 times x. That's 65x. Let's bring our friendly calculator back and clear it out and do 40 times 39. That is 1,560. 65 is still my coefficient. You might already know how much blue paint before we even get to this part, because you might have done it a little bit differently, and I'll show you that in a moment. Anyway, 65 is my coefficient, so divide by 65. That gives me x right here. Let me clear this up. Let's do 1560 divided by 65 equals 24. So Jason needs 24 gallons of blue paint. All right, so 24 gallons of blue paint and 15 gallons of red paint. Now, I said I'd show you a different way to do that. Here's the other way, and you can use this as a check, actually. For this second part, for the inside of the house, Jason needed 39 total. If you take away the 15 that we figured out for red, you're left with 24 for blue. If you take away what we figured was the red, you're left with the blue. So that just gives us a check. That's our check of the work we did. Okay, so now that you have done both of these, you take this paper to Mr. Willmarth or Mr. Christman, and you give it to them, and that's your passport to take the intervention test.